Let's see an application of differential calculus and how it can be applied to solve a real-world problem. Here we have a shoe company that sells X shoes. So X is the number of shoes that they sell. But there's going to be a lot of variables floating around. So let's maybe start writing them down. X is the number sold. And P is the price per pair of shoes. Now, we all know that if you change the price, the demand is going to change, right? If you raise your price, demand is going to drop. If you decrease your price, demand is going to increase. So the demand X fluctuates according to the price according to this equation. So that's the number of shoes I sell. That's the price per shoe. That's the relationship. Now, the question is, what should the company charge per pair to maximize our revenue? So we're looking for a revenue equation. And the revenue is going to be the number sold. In fact, I don't know why I created a new variable for that. It's called X. The number sold times the price per shoe, right? Like if we sell 2 shoes at $5 a piece, then it's 2 times 5, that gives us $10. So number sold times price per shoe is going to give us our revenue. And because we have the equation for price of the shoe right here, we can replace price of the shoe with 10 minus 0.001x, which leaves us with a quadratic function, 10x minus 0.001x squared. So it's going to be a concave down parabola with a 0 at 0, right? If you sell 0 shoes, then your revenue equation is 0. And there's going to be some other 0 over here. Now, let's use calculus to find out where this peak is, where the maximal revenue is. So we know by calculus that the maximums or local extremas, minimums or maximums, can only occur when the first derivative is 0 or does not exist. This is a polynomial. Its first derivative is going to exist everywhere, so we really only have to worry about when the derivative is equal to 0. Right? This derivative, again, is a polynomial. It's the derivative of another polynomial. So it's going to exist everywhere. It's going to equal 0 when x is equal to, oops. So it's going to equal 0 when x is equal to 5,000. By just solving that equation, setting your derivative equal to 0, solving for x, it happens when x is equal to 5,000. So here's 5,000, which gives us our maximum. So we need to sell 5,000 shoes for our maximum revenue. To figure out what is our maximum revenue, we just need to evaluate the revenue equation at 5,000. So plugging in 5,000 into your revenue equation, you get $25,000. So your maximal revenue is $25,000, and it happens when you sell 5,000 shoes.